This video was intended to be a review of this i3-N305 NAS Motherboard by CWWK. Unfortunately, I ran into a couple of issues after I started doing some testing, and I didn't want to spend a lot of time evaluating it if the board was actually faulty. Now, the two issues that I have are that one, some devices would not work in this PCIe slot here, and second one is that the system would occasionally hang or crash without warning, even with only SSD and RAM installed. But I will at least provide a basic evaluation of this device and run a few basic benchmarks. I bought this board about 2 months ago from Amazon, shipped by CWWK, so it is outside of the 30-day return window. I'm currently several days into a back and forth chat with CWWK customer support. It's been a bit difficult since they're in China, which is over a 12-hour time difference, but also the language barrier. As of yet, they haven't approved an RMA, so I guess we'll see where this goes. But if you're still interested, you can buy this board directly from CWWK's website. I also found it on AliExpress and Amazon where I purchased it. It comes as either an N100 or N305 CPU variant, and I opted for the N305 version. So following is my overview of the device as it stands as I received it, with the understanding that there may be some issues going forward. Hopefully I can get this resolved in the future, and I'll do an updated video. This is the CWWK N305 NAS ITX Monster Board. Now that's a mouthful, but it kind of explains exactly what it is, right? So it does use the Intel i3-N305 CPU, which is under this copper heat block here. The CPU is soldered on, and since it is a 15-watt TDP, they do recommend additional cooling, so something like this heatsink here. And they do offer a couple options when you order this off their website to either get this Johnsbow version or a different version of fan and heatsink. It does not come with a heatsink by default, though. It is an extra option that you have to pay for. So if we take a quick look at the N305 at Intel's website, compare that with the N100, which is the other variant that you can get on this motherboard, what I like about the N305 is that it's 8 cores, 8 threads versus 4 core, 4 threads with the N100. It's also a little bit faster at 3.8 gigahertz versus 3.4. Granted, you do have a higher TDP, which is why it's probably a good idea to have a heatsink and fan for this. And then the GPU is also supposed to be a little bit faster with the 1.25 gigahertz versus 750 megahertz and 32 execution units versus 24. And it is an ITX form factor, and we'll go ahead and take a look at some of the options and ports that are on this guy. And first of all, we take a look at the back here. You can see that we've got the two USB 2.0 ports, type A, and then a full-size display port, an HDMI port, full-size, then a USB 3.2 type A, USB 3.2 type C, and 4 2.5 gigabit Ethernet ports, which I believe are the Intel i226V chipset, which seems to be pretty common for these types of boards. It does use DDR5 SO-DIMM, and there's a single slot here for that, and I believe it can support, they say this only can support 16 gigabytes, but so far everything that I've tried, the N.2 NVMe the N100 seems to support 32 gigabytes anyways, so I'm going to go ahead and throw a 32 gigabyte chip in here eventually. And then you've also got this USB, a couple of more USB 2.0 ports here, and they do have a PCIe 1X slot here. That slot is open-ended back here so that you can actually slot in a PCIe card larger than 1X, and they did separate the pins here and the SATA port so that you can actually slide it in between there. We'll show that later. I do like that they offer that option. And we do have the two M.2 NVMe ports right here, and these are PCIe 1X lanes, only PCIe 3.0, and this CPU only has 9 PCIe lanes, so you're kind of limited in that performance that regard, but it is good to see a couple of NVMe slots here. Future update here, clearly you can see that I've got the heatsink and fan in here now, and I thought I should also mention that the model number of the board is the CW-ADLN-NAS, but more importantly is the fact that this M.2 port and this PCIe slot share the same PCIe lane. So you can use either one or the other, not both. Now I'm not sure why that is, because there's N100 variants of this board, N.2 variants of this board, and the N.2 has 8 PCIe lanes, the N100 has 9 PCIe lanes, this one has 9 PCIe lanes, but regardless, you can only use one or the other. And then we look over here, we do have 6 onboard SATA ports, and the chipset for that is underneath this heatsink here, and I will pull that off later. You can see that's the JMicron JMB585. And then of course we've got the 24-pin ATX power supply, as well as the 4-pin ATX CPU connector that's required for the CPU, then a couple of 4-pin fan headers there. Now if I go ahead and flip this guy over, take a quick look at the back, and you can see here that we've got some extra chips here which are related to the 2.5 gigabit Ethernet chips, I believe. We'll take a closer look at that. And then you can see you've got 4 screws which holds down the copper block for the CPU here, and then also the 2 pins that hold down the heatsink for the SATA controller to cool the SATA controller here. Now I do plan on removing both of these eventually, and but I wanted to go ahead and get a baseline for performance as far as thermal performance before I go ahead and do that. So I'm going to build everything up and run benchmarks that way. Then I'll go back and remove this, and I'll show a quick video to show you what's underneath there, and then I'll repaste everything and go from there. So I did install Windows 11 Pro and Ubuntu on this device, and like the other motherboards similar to this, Ubuntu installed just fine, detecting all the devices, no problem. Windows, on the other hand, similar to the other devices, there were a number of undetected devices, at least with the initial installation, like the Ethernet controllers, which I had to grab those from the Intel website. And then there's a couple of PCIe devices on there as well. But after I did a full Windows update, there's only one device that was not detected, and that was the high definition audio device that you can see there. Now, after doing some digging around, I did find on the ASRock website drivers for that Realtek high definition audio driver, and you can download it there. That's the only place I could find that was reliable. But once I installed it, everything updated just fine, and the audio device was detected no problem. Now, if you're wondering if you can actually run this without a heatsink and a fan on it, I'm running Cinebench right now, and about 6 or 7 minutes into it, and we are already thermal throttling. So if you're running any kind of load on this thing, I think you still need some sort of cooling fan. I'm testing this without any type of cooling. I'm also going to be running it with this fan just kind of at low, just passing air over it. So in case you want to run it like in a case with just the case fan running over it, maybe that will be sufficient, but we'll take a look at that as well. Now with that fan sitting off to the side running at low RPM directly across that copper heat block without any heatsink or fan on top of that, you can see the results here from Cinebench R23, and unfortunately I did not reset the min-max values here, but you can see throughout it did run at about 75 Celsius, so just getting a little bit of air across that heat block actually helps. Okay, so after much trial and error, it looks like you have to orient this a certain way. I'm still not happy with it because if you look here, hopefully you can see that, when you orient it like this, it looks like the capacitors, or the bracket of the heatsink, touch down to the capacitors there. And so when you go to tighten this, I'm afraid of squishing those capacitors. It does seem like it's making good contact with the copper heat pipe there, or heat plate. So I'm only going to hand snug it for now, and I'm going to contact CWWK to see what they recommend, because they do offer this as an option for a heatsink for this board, and any other orientation would interfere with something else. So it seems like this is the way it needs to go, and based on the graphic on the back here, it makes it look like I have it oriented properly. That's where the heat pipes go, right? There's where the brackets go, so we'll see. Just makes me a little nervous that it's touching down to those capacitors. Now here's the run with the actual heatsink and fan on top of that copper heat block, and you can see here that the results are pretty strikingly improved, running at only about 37 to 38 degrees Celsius. So here's a quick look at the BIOS, and most of these boards have a ton of options in here, although they don't always necessarily affect the system. But I have used the hardware monitor here and made changes to here so it would actually adjust the fan, otherwise it would run pretty much full tilt. But this will actually, if I set this to 40, this to 50, and then it tends to effectively just sit idle most of the time until it goes under load. So I booted into Windows, and I am pretty much sitting idle, and the power consumption is right around 19 watts. And you can see all I have is the single SSD, HDMI cable, a couple of network cables, and then the USB dongle for the keyboard and mouse. So I have Windows 11 Pro installed on here, and I'm going to check the throughput of each of these I/O ports, and everything from the M.2 drives to the PCIe slot to the 6 SATA ports with the JMB585 SATA controller to the 2.5 gigabit Ethernet ports, and the two USB 3.2 ports, both the USB-C and USB Type-A, and then if we can support 4K 60 or more out of the DisplayPort and HDMI. And then this also has a 32 gigabyte DDR5 RAM module in there too. And I'll go ahead and run this through Windows real quick, get some performance benchmarks, then also do the same thing in Ubuntu. So in order to accomplish this, I'm going to be using this Samsung 870 EVO 2TB SSD to check the performance in each of these individual SATA ports, because this can achieve about 570, 580 megabyte per second sequential read-write, and that's through the JMB585 SATA chipset. In addition to that, I'm going to be connecting up 6 of these Samsung 850 EVO SSDs in a RAID 0, so we can check the maximum limit through the PCIe 3.0. It should be a 1x lane, so we should see no higher than 1000 megabytes per second. And of course, I've got the two M.2 drives here. This one's the boot drive, the Patriot P300, not a real great performer, but it should be able to push the limits of that slot, PCIe 3.0 1x. And then I've got this WD Black SN770 SSD, 2 terabyte, so that should be plenty to check the performance of the PCIe 3.0 1x lane. And the PCIe 1x slot, and I have a number of adapters to check in there. I've got a couple of video cards, a GT710 and a GTX 1050 Ti. Neither one require external power. And I've got a SAS and a SATA adapter here I'm going to throw in there, and then also a PCIe to M.2 NVMe adapter, which I'm going to throw in probably this Samsung 970 EVO Plus in there, which I'm also going to be using to check the USB performance out the USB-C and the USB-A ports there with this adapter. And additionally, I'm going to also check the 2.5 gigabit Ethernet port performance, and then also the HDMI and display port, and checking to see if it can at least support 4K 60 Hertz out to the monitor. So first up, I've got the two M.2 slots here populated with these M.2 NVMe drives, and I'm going to check the performance of those using Crystal Disk Mark in Windows here. The C drive, we've got the Patriot M.2 P300 256 gigabyte SSD. You can see here it is PCIe 3.0 X1 transfer mode, so that kind of confirms that it is PCIe 3.0 X1 lane only, and the SSD itself is PCIe 3.0 X4. And then as far as the D drive here, I've got the faster WD Black PCIe 4 X4 lane, and it's again only running at PCIe 3.0 X1 speeds. So I'm going to do a quick sequential test on both of these just to verify that. So here's the Crystal Disk Mark sequential read and write results, and they're right around 900 megabytes per second read and about 800 megabyte per second write. So that's right up where it should be in the PCIe 3.0 1x lane. So next I'm going to test out the network connection, and I'm just going to test the one for now and make sure we're getting the 2.5 gigabit speed. If we go ahead and do a IP config, we can see here that this 192.168.25.20, that's one that I have configured as 2.5 gigabit. And there it just locked up on me. Great. Okay, we're booted back up. Let's go ahead and take a look at that network connection again. And you can see here, this is the one that's 192.168.25.20. That's on the 2.5 gigabit Ethernet switch. And we go ahead and this should be connected to my desktop. And sure enough, I can ping it, so we're good. And that one is running an iPerf3 server. So we can go ahead and do a iPerf3 bidirectional C192.168.25.10. You can see there that we're getting 2.37 gigabits per second. So both sender and receiver are both 2.35 gigabits per second, which is about what it should be. All right, real quick, we can see here that we've got 32 gigabytes of RAM installed, and it's detected here, no problem. So next I'll go ahead and test out the USB ports, and I will just use the Type A adapter here, then I'll swap that out for a Type C connection for the other port. So let me go ahead and plug this into the Type A. Okay, so it's detected, and I've got this 1 gigabyte folder. You can see here it's a total of 10 gigabytes. So I'm just going to do a click, copy, drag. I'm not going to do anything fancy here. You can see here it's getting right around 1, of course in traditional Windows fashion, it oscillates the performance. But there you can see we're getting right around 1,000 megabytes per second. All right, now I'm going to take that same file and drag it back onto the SSD. A little bit slower, 600 megabytes per second writing out through the USB port. Now I'm going to swap it for a USB-C to USB-C cable. So again, we'll do the same thing. 10 1 gigabyte files, click and drag from USB to the M.2 SSD, SN770. So now the folder is on the SN770. I renamed it to 1 gigabyte _1. I'm going to click and drag it back to the USB drive SN770. And we can look at the performance here. Again, we only get about 600 or so megabytes per second when we write to the USB. Now for this next part, I'm going to plug in this Samsung 870 EVO 2 terabyte SSD into the SATA ports. I don't think hot swap is enabled. I'm going to try and enable it in BIOS so I can actually just plug it from one to the next and next and next and do a quick performance test. All right, so the SATA Samsung 2 terabyte SSD is detected. And now this one is half full. I've been using it for other things, but you should get a good reading anyways. I have it selected here, drive E. So there's that performance for port 1. All right, now I'm going to see if hot plug works. I'm going to disconnect, plug it back in this guy, and it is not hot pluggable. That means I have to reboot every time I connect to a different SATA port. Not fun. All right, so this is weird. For the first 3 ports, I could not hot swap the SSD, the SATA SSD. Now this time on ports 4 and 5, I could hot swap it. It would detect it right away. I'm going to try it again, moving over to SATA port 6. And poof, it pops right up. All right, so if we quickly take a look at the results here, you can see here's SATA 1. It's 560 read, 530 write, 560 read, 525 write, 560 read, 530 write, 560, 530, 560, 530, 560, 530. So they're all pretty much about the same. All right, now for the fun part, I'm going to connect these 6 250 gigabyte 850 EVO drives to the motherboard here. All right, so I have them all hooked up here. I'm going to go ahead and power on. Now I combined all 6 disks into a RAID 0 striped array in disk management here, and it is drive letter S. And we can go properties. See here it is 1.36 terabytes, so 250 times 6, right? That's going to be roughly 1.5 terabytes. So you can see here we've got disk 0, 1, 2, 3, 4, 5, all Samsung 850 EVO 250 gigabyte. And I have drive S selected here. Go ahead and do the crystal disk mark sequential test. And it locked up. Great. All right, I'm going to swap out the 32 gigabyte RAM chip for the 16 gigabyte RAM chip and see if that helps matters. Maybe it's a RAM problem, but I did run this earlier and I still had a lockup, so we'll see. All right, let's try this again. Hope it doesn't lock up. We've got disk 0 through 5 here, combined in a RAID 0, drive letter S. So you can see here all 6 SSDs combined can hit the 1000 megabyte per second performance cap of the PCIe 3.0 1X lane. All right, so now I'm going to check for 4K 60 support with the built-in HDMI port. For whatever reason, I'm only able to get 1080p out of the HDMI port. It's the maximum resolution that it will support for some reason. So next I'm going to go ahead and check the display port, see if we can get 4K 60 out of this. With DisplayPort, it looks like we can hit 4K no issue, 4K. And crashed again. Okay, so we rebooted after the crash, and let's get a look at this real quick. 3840 by 2160, so 4K with DisplayPort, looks like it's possible. Go down to Advanced Display. You can see over here that we are 60 Hertz here, and we can choose between 60 and 30 Hertz, and it crashed again. Now lastly, I'm going to be hooking up the PCIe devices here. Well, at least I actually kind of did, and I had some issues there, and I brought it to the attention of CWWK, and they asked me to provide a video, so I put together a quick video showing them my concerns, and I'm going to show you that now, and because I think it shows you that, I think it may be a power issue or something, I don't know, but only some devices work on here and others do not. Alright, so here is my motherboard. I have this SSD in here. I've got this 16 gigabyte RAM stick. I have a number of different cards that I'm going to be trying on here, and I have this SATA adapter. I have this 1050 Ti video card. I have this PCIe to NVMe adapter, and I have a GT710 video card, and also an LSI to SAS/SATA adapter card here. This is hooked up to the Silverstone 300 watt power supply. Okay, here's the BIOS version. Okay, first I'm going to install this GT710 video card. It doesn't require any additional power. I'm going to plug HDMI into the back. So you can see here it's detected. Obviously we're getting output to the screen. Everything is fine there. So now I'm going to take the 1050 Ti. It does not require external power at all. Plug it in here. I'm going to plug the HDMI into the end. Powered on. So the fans are spinning, but I'm not getting anything out on the display. So if I remove the HDMI and plug it into the motherboard, we get signal. And if we go into Device Manager, display adapters, there's no 1050 Ti listed anywhere in here. Next I'm going to take this PCIe to NVMe adapter here. I should get lights along here, but I don't. Go into disk management, it's nowhere to be found. Not showing. Now if we go on the BIOS and go to chipset, PCI Express configuration, set that to CEMX4 slot, it's not detected anywhere. I'm going to take this same SSD and put it in the M.2 slot. And this is still set to CEMX4 slot, so I don't think this even matters. There it is, Samsung 970 EVO. So the disk SSD actually works fine in the M.2 slot. Alright, so I've got this Samsung 2TB 870 EVO SSD, SATA SSD, hooked up to this SATA cable to the LSI PCIe adapter card with the SAS adapter here, and then I'm going to go ahead and boot it up. Alright, so boot it up into Windows, and you can see here there's no SATA drive there. Go to Device Manager, Disk Drives, it doesn't show up there. Go to Disk Management, doesn't show up anywhere here. Now if I take the SATA drive and I connect it directly to the motherboard, I guess I have to reboot. Okay, so I rebooted with that SATA drive connected to the onboard SATA port, and you can see here it's detected. So it's definitely not getting seen by the LSI controller. I do have a second LSI controller here that I tried as well, same result. And you can see that the heatsink is pretty hot, so it's definitely getting some power. So I don't know what's going on there. And then lastly, I have this standard SATA controller card. Got the same SATA SSD, but I'm going to plug it directly into this. Go into the desktop here, and you can see that it's detecting the Samsung SSD as well. And there it is. So it works fine with the SATA card, but not with the LSI controller card. I just wanted to clarify that anytime I plugged a PCIe card into the slot here, I did not have anything in this M.2 slot here. It may not be clear in the video, so I just want to clarify that here I only had the M.2 boot drive in this slot here. Because I understand that this slot and this slot are tied together with the same lane, and you can use one or the other. So this one was empty anytime I plugged something into the PCIe slot here. Now, one more issue I've been having is it's been locking up, and it's random, right? It's not like it happens every 2 seconds or every 5 minutes. Sometimes it's 5 minutes, sometimes it's 30 minutes, sometimes it's an hour. Now, I have the 16 gigabyte RAM chip in there. I've also tried the 8 gigabyte variant of that, as well as the 32 gigabyte variant of that. And they all had the same issue. So if I let this sit here for an hour, 2 hours, it might hang up, it might not. So that one, it's hard to demonstrate, but it happens. Well, as you can see from earlier in this video, I did end up having those crashes and hangs, but I wasn't able to recreate it for the video I provided to them at the time. Now, I also attempted to run a few benchmarks in Ubuntu. While I had no issues installing the OS, and it seemed everything was detected properly, I ended up getting occasional hangs and lockups within Ubuntu as well.
Front, right. Front, left.
Here I just did the audio test, and now it just locked up. So it's not just Windows, it's also Linux. So I decided it wasn't worth the effort to continue at this point, since it was pretty obvious that this motherboard had some stability issues. I did do some rudimentary digging into the error logs, but I couldn't really find anything concrete other than the mention of GPU. While this single board that I have here is not necessarily an indication of how all these motherboards will act, as this one is probably just faulty, another user at the Serve the Home forums indicated that they had a similar situation, at least regarding the PCIe port. While I can appreciate that the board can't power a 75-watt TDP video card, the fact that it doesn't work with an SAS card or an M.2 NVMe adapter makes the port pretty worthless. Considering that CWWK offered their new purple board, the CW-ADLN-NAS, which seems to offer a similar feature set but fully functional 2 M.2 slots in addition to a 4x PCIe slot, although I think that the slot is actually just 1x speed, I'm not sure why this current board that I have here actually exists. So sorry to leave you with an incomplete review, but I already dumped a dozen or more hours into this project and figured I'd at least share my results so far. Hopefully this gets resolved through CWWK in the near future. I'm actually going to try to exchange this board for the purple board if I can. So thanks again for watching, and I'll provide a follow-up video if there's any positive progress made.